Here on my jumbled mess of wires on 3 breadboards, my power supply. I've got my output voltage, my output current, my simulation time and which mode I'm currently in on my LCD screen here. And these are the actual numbers, and only off by about 20 millivolts and 20 milliamps or so from the real values. This is my Arduino. I use the FTDI programmer here to program the microcontroller. Now these two capacitors here are my low pass filters that was used to convert the PWM to a DC voltage. That then gets fed into my amplifier to give me 0 to 20 volts output. The output of the amplifier feeds into my my regulator here, and I use the voltage divider here to measure the output voltage of my regulator. To measure the output current, I use a differential amplifier here, and I'm measuring across this 1 ohm resistor. This is my dummy load here. This is the MOSFET. I've got 10 ohm resistors, all connected in parallel to give me a 1 ohm equivalent resistance. So this way I can put a volt across here and know that I'm drawing an amp through the dummy load. And the dummy load is currently connected to a 7805 linear 5 volt regulator. This right here is my rotary encoder. I can use this guy to adjust the output voltage. Go up, down, leave it at about 8 volts or so. Now my oscilloscope screen here, the yellow represents my PWM coming out of the Arduino, and the blue is the output from the low pass filter. I'm getting a reasonably smooth output signal, which is giving me pretty smooth regulation on my linear regulator. Now back on the computer, I'm displaying again the output voltage, the output current. I'm also displaying the amount of power I'm consuming. I'm displaying the load voltage, the load current, and using that information I can calculate the output power and the load power, which will then give me the efficiency of this regulator here. I can also simulate use the power supply to simulate by first you push on this. So now you're no longer in DC operation mode, you're in min mode. This allows you to adjust your simulation time in minutes. You push on this again, you'll now enter second mode. You can adjust the seconds, do a simulation of about 30 seconds. Now when I push on this one more time, the LED will change to green and my time will start at 0 and increment up to 30. So looking here on the screen, I can, if you look at this voltage, that is my simulated voltage. Now drop down to 0 because I reached my time to start to enter low power mode. Now this comes back up. So now looking back over here, once I reach 30 seconds, this LED will turn to red. This lets me know that the simulation has finished, and meanwhile the whole time I'm recording the efficiency. And once the simulation is finished, simulations can run up to 90 minutes or so. So in case the user gets bored and doesn't feel like sitting by this whole time, once the simulation is done, the LED turns green, the output power will also drop off down to 0. Now, in order to exit simulation mode and get back to DC operation mode, push on this one more time, turns back to blue, letting you know that you're back in DC operation mode, and you also have your DC displayed again. You can continue to adjust either your output voltage, or using this pot, you can adjust your load current up to, I've been able to draw a little over an amp or so.